Okay, so we're talking about what happens when carbon-14 undergoes the three different types of decay. Not that it does all three, but if it did. So it starts out, carbon-14, 6 protons, because its mass number, carbon, is 6. Carbon-14 has to have 14 things in the nucleus, so it has to have 8 neutrons for a total of 6 plus 8, 14 things in the nucleus. And then, of course, if it has 6 protons, it'll have 6 electrons. If it undergoes alpha decay, it emits 2 neutrons and 2 protons, which is the helium nucleus. If we subtract 2 protons from 6, we get 4 protons. If we subtract the 2 neutrons from an 8, we get 6 neutrons. So anything that has 4 protons is beryllium, and anything that has 10 things in the nucleus will be an isotope with the number 10. So this is going to be beryllium-10. So when carbon-14 undergoes alpha decay, it becomes beryllium-10. That would be to kind of answer that question quickly. All right, so Jenna, what's next? Beta on your sheet? Beta. So if carbon-14 undergoes beta decay, then what's going to happen to its nucleus?
It would gain a proton.
Okay, it's going to gain a proton. So instead of 6, it'll have
7.
And what else?
So it loses a neutron.
It loses a neutron because that neutron becomes a proton. So it had 8, now it has 7. And we don't really mind about electrons so much to determine what it is. So what element will it be with 7 protons?
Nitrogen.
Nitrogen has 7 protons because its atomic number is 7. And how do I figure out what isotope of nitrogen?
You add protons, neutrons, so 14.
All right, so this is going to become nitrogen-14 when it undergoes beta decay. And that is a nice, stable, happy isotope of nitrogen. It's the most common one. And nitrogen is a very common element in creation. So then gamma, I guess. Elise, well, I already talked to you. So Ava, if carbon-14 underwent gamma decay, what would it be? It does. So it will remain carbon-14, but it would just be shooting out gamma rays, electromagnetic waves that are high energy, very damaging to you. Now, does anyone know which one actually happens? Chris?
Alpha?
No.
I think beta decay happens because we know that carbon dating, radiocarbon dating, happens because most carbon is carbon-12 in creation, and carbon-14 is unstable. It decays. It has a half-life, which I bet your book even told you during this module, but yet I can't remember. I don't memorize fast anymore. Do you guys know how many years?
5,700 years.
Okay, so when I say half-life, what does that mean? Oh, hold on, I have to text something else.
It's how long it takes for the radioactive activity to go down.
It does go down. So if you say half-life, and the half-life is 5,700 years, Chris?
So every 5,700 years, the mass would decrease by half?
Yes. So you take, if you have a sample, and say it's pure carbon-14, which of course we know is not going to happen. Very rare do you have carbon-14. But let's say we had this. Let's say its mass was 5 kilograms. Okay. If you go that half-life, if that's say 5,700 years, then what will have happened to half the 5 kilogram mass? Half of it would have undergone decay and become nitrogen-14. The other half would still be radioactive carbon-14. So half your mass decays into whatever it decays into in that time period of your half-life. So if you have an element that has a half-life of 200 years, half its mass will turn into the other thing every 200 years. The other half will remain unchanged. And that's why the nuclear waste from fission reactors is so dangerous, because its half-life is so long that essentially it's going to be their eons. Like
In other words, don't let it loose.
Yeah, you need to contain that stuff and never ever let it loose. Did we do all three? We did all three.
Mm-hmm.
Okay, so let's talk about study guides, and then I will film you guys instead of my skirt. This is 13. Okay. How far did we get on the study guide this week? We did not do number 13. Or 7.
Last two to number 7.
Okay.
So then this week you started.
All right. So let's just start at number 7. Oh, we did. I remember number 7, I think. How many protons does the second atom have? Let's start at 8, because I really kind of remember doing 7. So Max, I'm going to start with you on 8. And it says this: 2 atoms are isotopes of one another. The first has 18 protons and 20 neutrons. The second has 22 neutrons. How many protons does it have?
It would contain 18 protons.
18. How do you know?
Because isotopes all have the same number of protons, just varying numbers of neutrons.
Perfect. That is such a key point in this module. Isotopes must have the same number of protons. They can have different numbers of neutrons. And if it has 18 protons, what element is it? Yeah, don't put your thing away.
AR.
Argon, AR, 18 is the atomic number of argon, so it has 18 protons. Noble gas, all the ones in that period are happy the way they are. They don't react easily with other things. All right, Patrick. Number 9 says, which of the following atoms are isotopes?
112 SN, 124 SN, and 120 SN.
Okay, so SN is 10, strangely. I don't know. And so you have to pick things that are the same element as each other. They have the same number of protons as each other. I had a student make a case on a test one time where they're all isotopes because, they might not be isotopes of each other, but they're all isotopes of something, and I had to give them credit. Don't do that. But pick the ones that are the same element as each other. We're asking which ones are isotopes of each other, okay? But exactly right. Number 10 is drawing. Bethany, will you come up and draw what the Bohr model says an oxygen 16 atom would look like? And I'll erase for you. And I'll first maybe hopefully film the board because I don't know if I really got it very well. Okay. And then I will stop making people sick. There we go. So Bethany's going to draw an oxygen 16 atom. You're welcome to either draw dots for protons or just write the number of them. And the periodic table is up there. Yes? Yeah, I should flip it around now.
So this,
You got the bad
I think
marker.
I got the wrong.
That's okay. You can look at that periodic table.
So it's oxygen 16.
So how many protons will oxygen have?
8.
8. How did she know how many protons oxygen has? The atomic number of oxygen is 8. So she decided on 8 protons. Now, if it's oxygen 16, how does she decide the number of neutrons?
Because you add protons and neutrons together.
Right.
Make the mass number, so you subtract.
Subtract. So you have 16 total things, 8 of them are protons. That means the other 8 must be neutrons. So she's getting dots for protons, dots for neutrons. And then you're going to use the Bohr model, so you're going to fill Bohr orbitals. So you just need to remember how many things can fit in each Bohr orbital. I should zoom the proper way. Oh, look at that. All right, so she put 2 electrons in the first Bohr orbital. That's right. How many go in the second? How many can go in the second?
8.
Okay, so you could put 8, but since you only have 8 total protons to balance that charge, you only need 8 total electrons, so you just put 6. She makes neat little dots, unlike my giant X's. So this is the Bohr model of an oxygen-16. 8 protons, 8 neutrons, and 8 electrons in their proper orbitals, like that. Thank you, that is perfect. Okay, Chris. This is number 11. Oh, you're drawing. So I should have had you come up and draw along with her. Drawing a magnesium-25 atom. So Mg is magnesium, magnesium-25. So we'll kind of zoom in right here and see what the atomic number of magnesium is. How many, and you don't have to draw dots, it's a lot of dots. So how many protons would you like? You are welcome to draw them if you like.
Yeah.
He wrote a 12, so I'm guessing he's going to draw 12 protons. And that is because magnesium has the atomic number of 12 on the periodic table. Please use your periodic table on the test. You will really be up a creek if you do not. If there are 12, oh, he's fast. If there are 12 protons and 25 total things, then how many neutrons? I'm guessing 25 minus 12 is 13 neutrons. Then he's putting in the Bohr orbitals, 2 in the first, 2 electrons in the first, 8 in the second. That's 10 total.
It's all on one side. It's messing me up.
Electrons repel each other, but they don't have the strong nuclear force holding them together, so they spread out, but they don't in any way do anything like a Bohr orbital in real life. So, how many total electrons is that?
12.
12. There are 12 protons, so there have to be 12 electrons. There have to be 25 total things in the nucleus to be magnesium-25, and that's perfect. All right, Joseph. What is the largest Bohr orbit in a uranium atom?
So, what do you mean?
The largest Bohr orbit. Like in oxygen's case, there are 2. Chris used 3 for magnesium. How many Bohr orbits would uranium have?
It would have 5 Bohr orbits.
5. And how did you figure that out? Because there is a question like this on the test.
I took the amount of electrons each Bohr orbit could do, and I added them up.
Okay. And feed me those numbers. So the first has 2.
Yeah. Then 8, then 18, then 32. And the next one is going to hold at 50, but it has 32.
Okay. So if we add it up here, it would be 110. How many electrons does uranium have?
92.
Where are we? 92 electrons. If it has 92 protons, it has to have 92 electrons. So if we didn't include, here's orbital 1, 2, 3, 4, and 5. If we hadn't included 5, right, we would have had way too few. That would be, what, 60? We need 92, so we must have that 5th orbital, even though we don't fill it, to accommodate our 92 electrons.